You can pick up a bag with a single hand or both hands according to the requirement. Similarly, atoms can hold each other with a single bond, double bond or triple bond according to the situation. Let's understand this in detail in this video. All of us are familiar with H2, O2 and N2 molecules. But have you heard of the He2 molecules? You might not have. This is because He2 is not a stable molecule. The stability of molecules is decided by the number of bonds shared between the pair of atoms. Let us understand this fact while we explore an important bond parameter called bond order of a molecule. Bond order is not only an index of its bond strength but also of its very existence. For this, let's take a closer look at some of the molecules and observe their structures. The difference in their structures is in the electron pairs shared between the atoms in a molecule. The number of electron pairs shared between the atoms or the number of chemical bonds that exist between a pair of atoms is called its bond order. Accordingly, in diatomic hydrogen, the bond order is 1, in oxygen, the bond order is 2, and in nitrogen, the bond order is 3. As the number of electrons shared between two or more atoms increases, they come closer and the distance between the nuclei is decreased. This increases the strength of the bond. Thus, the bond order indicates the stability of a bond. Bond order can be calculated using the molecular orbital diagram and is given as half the difference between the number of bonding and anti-bonding electrons. To calculate the bond order of hydrogen, let's look at its molecular orbital diagram. Hydrogen has one bonding and one anti-bonding molecular orbital in which the two electrons get filled in accordance with the Aufbau principle and Pauli's exclusion principle. Both the electrons are filled in a bonding orbital and the anti-bonding orbital remains empty. From the given formula, its bond order is calculated and it comes out to be 1. This shows that a hydrogen molecule has a single bond between its atoms. Now let's have a look at the molecular orbital diagram of helium molecules. 4 electrons, 2 each from 2 helium atoms, fill up sigma 1s bonding orbital and sigma star 1s anti-bonding orbital. This means there are 2 bonding and 2 anti-bonding electrons in a helium molecule and the bond order emerges to be 0. This implies that no bonds exist between the helium atoms and helium molecules, He2, do not exist. What will happen to molecules such as oxygen, which have more than one electron pair shared between their atoms? Let's find out. The resulting molecular orbital diagram of O2 is as shown. Here we can see that there are 10 bonding electrons and 6 anti-bonding electrons in the molecular orbital diagram and the bond order works out to be 2. To summarize, bond order is the number of electron pairs shared between the atoms or the number of chemical bonds that exist between a pair of atoms. It can be studied to decide whether the molecule exists or not. As we saw while studying helium, molecules with bond order 0 do not exist. We also concluded that higher the bond order, higher is the stability of that molecule. Can you determine the magnetic character of diatomic molecules on the basis of molecular orbital theory? We will discuss it in the upcoming videos.
Keep imbibing. We believe in you.